to basic electricity. This is very exciting because we never did anything like this before. We're trying to imagine that we could have an educational experience together. And to facilitate this, I'm very happy to welcome good friend Rob Hordijk from the Netherlands, and he's going to explain about vibrations and oscillations and frequencies and resonances and some other things. Okay, you're welcome. I hope you enjoy Rob's talk.
Okay. Well, welcome everybody. My name is Rob Hordijk. You pronounce it as I, which is a certain Dutch kind of weird character, I and a J, and many people on the internet see it and they sort of change the letters and call me Hordijk or something, but that is totally wrong. It's Hordijk. I'm a builder of electronic music instruments and designer of electronic music instruments. And I always say specifically electronic music instruments, because you also have electronic musical instruments. But electronic musical instruments are basically all musical instruments that work with electronics, so that includes things like samplers and drum computers and lots of other boring stuff. And but when it is about electronic music, it means that basically it is specifically meant for the genre of electronic music in basically the most broadest sense there is. There's a couple of different sort of things that I do. Basically, tonight we will be talking about a modular synthesizer, and a modular synthesizer is basically an instrument that is sort of totally free to program yourself and make stuff. But there's also other things that I like to build, and there's going to be a concert in the cellar tonight, and people using a little device called a blipper box, and that type of instrument I always call a patch in a box, because it is sort of like a concoction of certain electronics that have a certain specific character of its own. It should be playable, of course. It can also be seen as maybe an objet d'art, what the French call that an objet d'art, an object of art, instead of an instrument. But that is basically free for the people that have one to interpret whether you want to use it as an actual musical instrument or stage, or if you just want to have it in your room as something special next to your paintings and your other stuff. Okay, I have not prepared anything for tonight, so it's going to be a little bit an improvised talk. Sometimes I have to do lectures, for instance, if I'm asked to talk for some university or conservatory. And then I, of course, have to prepare, because they're students, and these students really have to learn stuff, and I have to tell the stuff that I have to learn, and I say, this is it, nothing else. But tonight, of course, is more free, so I don't want to call this a lecture. And then Richard said, yeah, but what do we need to call this? And I said, well, maybe let's call it a clinic. So the idea basically meaning that I might start explaining something, but then it turns out to be quite an interesting patch, and I start to play it a little bit, and then maybe it can even become a little bit like music. And then at a certain moment I might just pull out all the patch cables and say, and now for something completely different. Okay, but there's some people here that already own one of these systems, and there may be other people that are interested, and there may be people that have no clue at all what they can expect from me tonight and from these machines. So I will try to mix a little bit some sort of specific information about this system, which is interesting for people that actually have the system, but try to also make it entertaining enough for people that have no clue what is standing here and just come for the music tonight. I'm not sure if I will succeed in this, because as I said, I'm improvising a little bit, but let's try. So, electronic music instruments, they have a very long history, and that history basically goes back to the 19th century when the first musical instruments were concocted that use electricity as a source to create sound. By the way, I am Dutch, so my native language is Dutch, which probably I know only one person in the audience understands. My German is terrible, so I'm speaking English. Is there anybody that has a problem with English here? Okay, so I will continue in English. So, the first electronic music instrument basically was a little contraption of a coil, and through that coil you could actually sort of conduct electricity, and there was a little magnet, and the moment when there was electricity going through the coil, the magnet was sort of pulled towards the coil. But when it was pulled towards the coil, it would also interrupt a little switch, and that would stop the flow of electricity, and the coil would go back, and then that switch would close again, and it would be pulled and released and pulled and released. And if you do that at a certain rate, at an audio rate, it actually makes a sound. And that is considered to be the first electronic music instrument ever conceived around the year 1860 or something. So electronic music is actually very old. It's not really just from the last couple of years. And this little contraption they improved later, because what they did to this magnet, they connected a little metal thingy with a little metal ball and let that hit a sort of a bell, and then it became our well-known doorbell. So, but a lot of things have happened since then, and basically in the 1950s, everything gets more into motion, and the most important thing that happened just before the 1950s, 1948, 1949, is actually the invention of the tape recorder. And because the tape recorder allows you to record sound instantly, but it also allows you to manipulate the sound, much more than, for instance, a record would do. You could also edit the sounds by cutting the tape in pieces and gluing them together in a different order. And you could reverse the tape, and you could play it at different speeds, and then you could re-record that, and that way you could sort of really build up a composition of electronic music from maybe starting only one sine wave or one sort of recording from some natural sound. And because of the tape recorder, basically a lot changed. So in the 50s, many composers started to get interesting in electronic music, because suddenly they could not only have a violin player play the violin, but then if they had recorded it on tape, they could do all sorts of manipulations and turn it into something completely different, something that was not possible to make in any other way. And then you see my improvisation actually starts with some history of electronic music, but maybe that's interesting to continue before we get to this thing. So basically what you see is that then there's two sort of streams, and one stream starts in Germany, and famous people like Stockhausen were part of this stream. And what they start to do is they start to record sounds and manipulate sounds with a tape recorder, but the origin of these sounds is purely electronic. For instance, sine wave generators, basically machines that were used in measurement techniques and all sorts of other more technical things. And at the same time, roughly the same time in France, people started to do basically the same thing with a tape recorder, but to use natural sounds that they recorded with a microphone. And so what the French were doing, they were calling musique concrète, and what the Germans were doing was called elektronische Musik. And when you look at it from an art point of view, art history point of view, then it's quite interesting because basically the difference between the two is the difference between surrealism and serialism. Surrealism, basically what the French were doing, and serialism, basically what the Germans were doing. But especially what's happening in Germany, and which very soon crosses the ocean and goes to the United States, is sort of using all these electronic measurement devices that actually can produce tones or can filter tones or whatever, but they didn't have a specific instrument that was sort of designed to do that. They really had to sort of go to the technical department and say, hey, do you have a device that sort of is able to give me a sine wave of 1 kilohertz or something? And then the technician said, well, we have this measuring device, and if you set a knob in this position, then it will give you that tone. And that's sort of what I had to work with, which of course was not a very practical situation. So already in the 50s they developed this idea of we need some sort of instrument. And actually my friend Richard Scott, he has just been in The Hague in the Institute of Sonology, and you have an electronic studio there that goes back to the early 60s. Actually it goes back to the late 50s. And in that studio you can see that originally they had the idea to sort of see a complete studio as one instrument. So they actually start to build all these little studio devices in a way that they can all connect together and become like one instrument. Mostly they use sort of like matrix patch panels, principle that I will explain a little bit later, to connect everything in a convenient way. And but of course to have a room with all this equipment that's all matched together and see that as one instrument is a very expensive operation, especially in the early 60s. So it was only a couple of well-funded institutes that were able to do that. And then composers were sort of invited to come there for 1 or 2 weeks and sort of try to make a composition with the stuff that they would find there. And these composers, after 2 weeks, mostly still didn't have a clue about how everything worked. But they had this idea like, well, maybe I would like this at home. And then, of course, you would need a more practical, compact kind of machine. One of the other issues that basically came up in this sort of the studio as an instrument situation is that you would like to sort of have some sort of remote control of everything. Because one of the nice things about this Sonology studio, because that still has stuff from the 60s and late 50s there, it is that you have this big room, all the equipment is in a circle around you, and when you work, you run from one side where you set a pitch to the other side where you set the level, and then you run back and do something else. And that's a lot of running around. So it would be very convenient if you could just sit in the center and you have this little console, and with this little console you can control everything. Now this was already recognized in the late 50s that that was needed, and I know that, for instance, in the WDR studios in Cologne, where Stockhausen worked, they already developed some root sort of remote control, mostly using relays that were switched on or off, but they could already set sort of gradual levels by using photovoltaic cells. And well, this need for control becomes more and more an issue, and in, let's say, 1963, you have this American composer Herb Deutsch. He wants to have a sort of a nice instrument for himself that where basically everything can control everything. And he knows this guy Robert Moog, goes to visit him and asks him if he can sort of make a device like that. And Mr. Moog says, well, I can do that. And very soon, 1964, actually the first so-called analog synthesizer sees the light. And basically, it has always there always have to be certain principles at the base of such a thing. And because if you don't work with the basic principles of sound, then it is very difficult to actually come up with something that is convenient to work, especially for an artist or a musician. So if you look at sound, at a simple sound, then there is three things in the sound that are basically separate, but they're always present in a sound, and that is the pitch or the frequency of the sound, so how high or how low the note is. There is the timbre of the sound, and there is the sound level of the sound. One of the brilliant ideas of, actually it is known now, of Deutsch and Moog together, is that if you sort of separate these three into three different kind of machines that work together, you can control these things separately, and thus the combination can create lots and lots of different sounds. Interestingly, I have here just one module where I can actually demonstrate this, because this little module here, it is called an oscillator. If I open this knob, you can hear that I can control the level of the sound, how loud it is. If I give it a certain loudness, I can also, with this knob, control the pitch of the sound. And if I set it to a certain level and a certain pitch, then with this knob here, I can actually sort of change the timbre of the sound, or choose a timbre with another character, or combine them and sort of create something that appears to have a certain life in the sound. And basically, all that a synthesizer does is is controlling these parameters by sort of a remote control. That means that if you have a little device like this to sort of play it, you need something that can play it, so can control it. And the way that it is used on the so-called analog modular synthesizers is that you control it with voltage levels. And a voltage is basically a voltage is not something physical there, it's basically a potential, it's a possibility. Only when the voltage start to interact with something else, like for instance a resistance, then a current begins to flow and something actually happens. But a voltage is basically, you have to see as sort of like a potential, something that can have a meaning the moment when it starts to interact with something else. And that means that it is actually very useful, because you can, the voltage can have the meaning that if it has a certain value, it will create a certain pitch, which actually happens when I play with this knob here, because here what I do is that this knob actually creates an internal voltage that goes between a negative value of maybe like 10 volts, volts is the unit for voltage, up to plus 10 volts, and then basically I can let it go from a very low rate up into a frequency that is actually present here. We don't hear it, but luckily the dog has gone outside because he would go mad now. So, all what you do with an analog synthesizer is basically create voltages, and these voltages all fluctuate in certain patterns, and then they are fed to devices that translate these voltages in either frequencies or timbres or loudness levels, and there you have electronic music. That's all there is to it, nothing more. But of course, the architecture of these synthesizers has certain traditions have grown over the last 50 years. For instance, there are very few people that would use only this module because, well, you just heard what it did, but it's not able to do much more than that. So if I connect this cable to here, then I can actually create a sound with a specific timbre, but then I have a knob where I can specifically control the timbre, and I can also add a resonance to the sound. Okay, then it starts to become a little bit more interesting. But mostly natural sounds, because basically these three parameters of sound, so basically pitch, timbre and loudness, they are not static things. Basically a sound is defined by how these three things change over time. And one of the things is that loudness always starts with silence, then it suddenly comes up, is there for a specific period of time, and then it goes back to silence again. I know some people that are into sort of mystic things, etc., and they have these sort of theories about eternal sounds that were there from the beginning of time and will be there in the end of time, you know, but it's very hard to use that in music. If you want to make music with a machine like this, basically you start with silence. Like now, we do have a pitch and we do have a timbre, it's silent, so you don't hear anything. So to make it move, I can sort of add a sort of a signal, and this time I will take the signal from an external source, which is called a little sequencer. It's this little high-tech Arturia device which is going to produce the most boring sequence ever for us today. And if I plug this plug in here and I plug this plug in here, and now if I open this volume knob, you hear nothing, because actually there is a little device built in here that is able to sort of open the sound and close it again, but it needs a little command on when to start, and for that I only have to press a button here, and basically I can open it for a very short time and immediately closed. I can let it come up slowly. I can also give it a sort of a decay, and play with it just until the moment when I think like, okay, maybe now it's got a certain feel, the sort of feel that I need for my song, and if I'm bored with it I just press this button here and it's silent again. So if I have this little sequence, it's now playing constantly the same pitch, but luckily there's another connector on this device, and if I connect that to here, then we can actually play also sort of like a melody. There it is. And like I said, today we're going to use the most boring melody ever, which is this one. So the moment when I'm sort of playing with this, I can start to play with this device that sort of sets the timbre. And I think, okay, that's funny, but it would be nice if I could also have this sort of timbral thing sort of play in time. And in that case, I just take a cable and connect it to an input here. And then if I open this knob here, am I doing it right? No, this one. We suddenly get this more sort of like, hey, wasn't there a guy